Significant figures can be used when we are talking about inexact numbers, or when we're talking about numbers that originated from a measurement. It's not really, well, this is how I look at it. It's a way of kind of expressing the value the best as we know it, given that instruments of measurement have limitations. Now, as you go on further in science and as you're studying more, you would use things like an error analysis to tell you how close your values are to the actual value. But significant figures are kind of a tool we can use to help us know how to best round the answers that we get when they when the numbers come from measurements. So there's a couple things that I need to point out here. The first one is significant figures are only used for inexact numbers. So then what we're talking about in an inexact number these are numbers that have come from a measurement. And measurements have some uncertainty because of the instrument that you're using. So, for example, if I had an instrument and it had markings on it, let's say these were the markings, and I'm just looking at a piece, and this line was a 10, and this line was a 20, and then I had little hash in between here. Well, so I know this line is a 10. That's a 10, and then I have 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I know all those numbers, but what if my measurement was between 15 and 16? Well, there's no line between 15 and 16, so I would have to estimate. And I could say if it was really close to the 15, I might say a 15.1. If it was really close to the 16, I might say, oh, it's a 15.8 or a 15.9. These numbers right here, I don't know for certain. They have uncertainty. I don't know for sure. So they're inexact. And this measurements, by their very nature, have their last digit is inexact. So you can see here, that's what this little paragraph says right there. The last digit, the farthest to the right, is an estimate, and it depends on the type of measuring device used. And as a result, we can use significant figures to kind of help us better know where to round these measurements that have an inexact digit. Now, if there's inexact numbers, it must mean there's also exact numbers. So what would an exact number be? Well, there's several cases that an exact number arises. One, it could be from counting objects that you have. So if I had a bowl of oranges and I took each one and I counted and I had 6 oranges, that's an exact number because I have counted it. There's not 5, there's not 7, I counted 6. So an exact number can arise from a counted number. The second time an exact number can arise is when it's part of a definition. So, for example, if I said how many sides are in a triangle, you would say, well, there's 3. Okay, so 3 is a number, but if I'm talking about 3 sides of a triangle, that's exact because that's a definition of a triangle. Another one which comes into play, if I said 1 kilometer equals, and I said how many meters, and you said, well, that's 1,000 meters. This is a definition, right? Because 1 kilometer has to equal 1,000 meters because kilo means 1,000. Or if I said there's 12 inches in 1 foot, okay, that number 12 and that 1 there, those are exact numbers because that's a definition. So we're going to talk about significant figures, but we don't apply significant figures to counted objects or to numbers that are a part of a definition. Now, with that said, also, generally in math, they don't think about significant figures, and even some science teachers don't think about significant figures, but I like to start thinking about the idea of having an inexact number. But in math, they're usually dealing with numbers, and so they just treat all numbers equally. They might not be thinking about measurements. In math, oftentimes you're trying to think about the formulas and the different functions that you're doing, and so you're not thinking about these measurements. Remember, significant figures are completely used for numbers that arise from measurements. So you don't have to talk to your math teacher about, although they may know about them, they won't use them when they're talking about solving problems. So there's two things we have to think about, and the first one is just a basic thing. It's the question, how many significant figures are in a number? And right here, these are the rules. And so what I would like to do is next to each rule, just give you an example of that rule. Okay, so it says all non-zero digits are significant. So if I had the number 1, 2, 3, 4, none of those numbers are 0, so this would have 4 significant figures. So anytime the numbers 1 through 9 are all significant. And so when we're counting how many significant figures, you'd count. There's 1, 2, 3, 4. So that would be 4 significant figures. If I had the number 835, then I would count 1, 2, 3. That has 3 significant figures. Okay, so then let's look at the other two rules. So this is the easiest rule. If you're not 0, you're significant. Okay, now there's 2 more rules. And I want you to look carefully because both of these rules have to do with 0. So the one rule has to do with numbers 1 through 9. And then you have other rules. It actually ends up being like 4 rules that only have to do with 0. So the guy that's going to get us in these significant figures is 0. Okay, so let's look at this rule here. So it says 0 is significant. Okay, when it counts. Here's the first rule, between 2 non-zero digits. So for example, if I had 205, they're talking about this number right here. So I'd have 1, 2, 3 significant figures. If I had, let's say I have 1007, even though the 2 zeros are next to each other, because they're between non-zero digits, I would count them. So it'd be 1, 2, 3, 4. Okay. So that's one case when it's significant. And then it says at the end of a number containing a decimal point. Okay, so 0 is significant when it's at the end. And then here's the important part. The number has a written decimal. So it's talking about being after a non-zero digit. So here an obvious one might be if I had 12.0. So I'd be talking about this 0. Here's the decimal. And so that would be significant. So I would count it. And it would be 1, 2, 3 significant digits. But it could also be before that number. So I'm going to erase these dots so I can, I'm going to write it a little higher. Sorry. So this is, I had 12 and that was 3. So let's say I have 250.0. Now, when it says at the end, it doesn't mean it just has to be the last 0. It just means it has to be after any non-zero digits. Here's my decimal point written, which was what I mentioned was an important part. And I have these 2 zeros, and they both are going to count because they come after a non-zero digit. So I'd have 1, 2, 3, 4. So I wanted to give that example because even if the 0 comes before the decimal, if it's at the end or after non-zero digits, if there's non-zero digits in front of it, then you're still going to count it as long as you have that decimal place written. Now I want to erase this up here because I'm going to make my other rule examples up here. So now this rule here, this also has to do with 0, but it says when it's not significant. So this is, we're not going to count it. And so the first one says at the beginning of a number. So at the beginning of a number, I would have, let me think of one. Okay, 0.0073. So they're talking about all these zeros here, and they're saying those don't count. If they come before a non-zero digit, even those that are a decimal, if they are before, they don't count. If they are after, they do. So these don't count. So this would just have 1, 2 significant figures. Right? And if I had 0.074229, these zeros don't count because they come before a non-zero digit. This would have 1, 2, 3, 4. And now I'm going to do a trick. 0.02930. So I put 2 zeros in there. These zeros come before, they don't count. This 0 comes at the end of a number after non-zero digits, it's going to count. So I'd have 1, 2, 3, 4. So let's do this very last one. So this says at the end of a number without a decimal point. Okay, I'm going to come way up here. Sorry, it's kind of messy, but that's fun. So at the end of a number, and here's the difference. So this was at the end, but it had a decimal point. This guy is at the end without a decimal. So we're talking about whole numbers. So we're like saying 1,000. No decimal written. And in your note, in your book, it will be written. So that would only have this 0. None of these guys count. All of those zeros don't count. This would just have 1 significant figure. If I had the number 250, that would have this 0 doesn't count because it's at the end, yes, but there's no decimal. So that just has 2 significant figures. Now, if you, let's see, if you see in your book and they write 250 and then there is a dot there, a written decimal, what they're doing is they're trying to follow this rule right here, down here. So that means that this number's at the end with a decimal. So you would count 1, 2, 3. So ponder that a little bit. This takes some practice. There's practice in, I have more practice online, and then there's also practice like in your homework, but you're going to have to ponder this a little bit. You might have to slow it down and stop it after each example so that you can kind of think about it. Now, we don't really care so much about significant figures independently, just by themselves, but we have to understand that because what we really want to do is use significant figures in calculations. So let's look at the rules for that. So the first rule is when you're multiplying and dividing. So basically what this is going to help us do is round our answers. Now when we round our numbers, we will say if the first number we're going to drop is 4 or less, we'll keep our last digit the same. If the first number we're going to drop is a 5 or greater, we'll round that last digit up. It's basic, very basic rounding rules. So multiplication and division. It says the answer that we have, the answer, has the same number of significant figures as the number with the fewest significant figures. So let me make up a problem. Let's say I had 17.5 and I multiplied it by 2.3. Got to get my calculator out because I'm making this up as you go along, and you can try it too as you go along with me. So what you're going to do is you just first do the math. It's always important to first just do the math. Don't worry about significant figures till you've done the math. So I multiply these two numbers and I get 40.25. Okay, that's the answer in my calculator. But to do significant figures, I would say this number has 3 significant figures. This number has 2 significant figures. So the rule over here says round your answer. Your answer should have the same number of significant figures as the number with the least or the fewest. So this guy only has 2. So I need to round my answer to 2. So I need a 4 and a 0. I'm going to drop off a 2. So I would write this number as 40. Now you might say, well, why would I put a decimal place there? Well, because that when you have a 0 at the end, if there's no decimal place there, then you don't count it. So 40 with no decimal would just be 1, but 4 and a 0 with a decimal would be 2. Okay, let's try it. Let's practice another one of these. We'll do 2 examples. So let's say I have 2530.1, and I'm going to multiply it by 0.2. Okay, let's see what we get. So now, just don't even worry about significant figures. Just do the math. 2530.1 times 0.2. And I get 506.02. That's what I get in my calculator. So to know where to round it, I go back to my numbers, and this guy has 1, 2, 3, 4, 5. That 0 will count because it's in between non-zero digits. And then this guy, this 0 doesn't count because it comes before the non-zero digit. So this just has 1 significant figure, just the 2. So I look, 1 is the smallest, so I just want to keep the 5. Okay, now I can't just write 5. If I just wrote 5, I have 506.02, and now I just have 5. Even though 5 has only 1 significant figure, it doesn't represent the same number. And if I was talking about cash, you would mind, because if I said, I'll round it to 1 significant figure and give you dollars, you would be like, $506 doesn't round to 5. So what you have to do, though, you can't, since the decimal is right here, right there, you have to put zeros as placeholders. So we'll put a 0 and a 0, and that keeps it at 500. Now I'm not going to write a decimal here because I only want 1 significant figure. This guy, I put the decimal because I wanted 2. If I put a decimal after that, the last 0, how many significant figures would I have? If you answered 3, you'd be right, because a 500 with a decimal at the end would have 3 significant figures because the decimal makes both zeros count. Okay, now let's look at the addition and subtraction. And again, I don't expect any time, even in my face-to-face lectures, that all of this is 100% clear the first time you hear it. If you're not familiar or haven't been exposed to this before, you might have to wrestle with it a little, ask questions, and think about it some in order for you to really understand it. So now let's look at the other type of math tool we could use is addition and subtraction. Notice here that we're not going to use significant figures here. It says the answer has the same precision as the least precise number, or the number with the fewest decimal places. So we're going to be looking for decimal places here. So let's say I take 2.05 and I add 1.6. So if I add that, just do your math first, I get 3.65. Well, my first number has 2 past the decimal. This has 2 past the decimal. The second number only has 1 past. And what the rules say is you want to have the least precise, or the one that has the fewest past the decimal. So I could kind of think I need to drop it right there. I only need 1 past the decimal. Now I'm dropping a 5, and so if you drop 5 or greater, you have to round the digit up. So I would report my answer as 3.7. So it's common for students to get confused here because they start using significant figures, but really we're kind of looking at the least precise or the decimal places. For example, if I had 8.470 and then I was going to subtract 2.1, I would say, okay, that would be a 0, that would be a 7, 3. I get 6.370. This guy has 3 past the decimal. This guy only has 1. So we want the least precise. So I draw this line down here. So I'm going to take a 6 and a 3. I'm dropping off a 7, so it's 6.4 would be my answer. Now, I haven't been using, remember, these are only used for measurements, and I haven't been using my units because in this section, I like to focus on the number part. But when you do your problems, oftentimes they'll have units associated with these numbers. The units won't change how you treat the significant figures. Okay, so I'm going to write a couple numbers down on this sheet as the last practice thing, and I want you to try to tell me how many significant figures. I'm going to write four numbers down. And one more. Okay, there's 4 numbers, and I want you to write how many significant figures down. And while you're doing that, I'm going to write 2 other math problems over here. Okay, so you can pause it now if you want. I'm going to go over now that I've written these down, but I just kind of want you to solve these. So how many significant figures in this one, as we go down the 4.076, this 0 is significant because it's in between, so I have 1, 2, 3, 4 significant figures. This second one, the zeros are not significant because they come before, so that would just be 2 significant figures. Here I have 2 zeros. Remember, anything that's not a 0 is always significant. This one is significant because it's in between, and this one is significant because it's after a non-zero digit with a decimal written. So this number has 1, 2, 3, 4, 5. And then if I just had the number 50 with no decimal place, this 0 would not count. On whole numbers with no decimal written, it doesn't count the zeros. So this just has 1 significant figure. Okay, now looking at the math problems. So always just do the math first. So you would just take 2.67 times 46.99. And I get in my calculator 125.4633. That's correct with math. But in multiplication and division, you want your answer to be rounded to the same number of significant figures as the one with the least. This guy has 3. This guy has 4. This one has the fewest, so I only need 3. So I need 1, 2, 3. So I'm going to drop it off there. This number's a 4, so I'll keep it the same. So I would write 125. Now in adding and subtracting, it's about precision. Go ahead and just do the math first. 11. Hopefully I'm adding it right. I'm just doing it this way. So I add it up. I get this number. The precision, oftentimes you can look at past the decimal. This has 3 past. This has 2 past. So I want the least precise. So I'm only going to go 2 past. This is a 4, so I'm going to keep it the same. So it would be 754.11. Because remember, when you're adding and subtracting, it's about precision. So you can look at the decimal places, not the overall significant figures. Again, I think I probably say this at the end of every lesson, but significant figures kind of take some practice. So find some examples in your book, in your homework, and if you have trouble with it, bring it to class or send me an email, and we'll try to get it worked out. It takes practice.